Right, so IBM has this product called DataPower, and during some security research I found a server-side request forgery exploit which could lead to remote code execution. The practical upshot of which is that if you have a low-level read-only account on DataPower, you can break out of the DataPower operating system and gain full root access to the underlying Linux operating system. And in this video I just wanted to walk through how I found it and give a little example. So first and foremost, what is DataPower? DataPower is an API gateway which can be configured with a wide range of security settings like OAuth, OpenID, JSON validation, XML validation to provide a security service for your API and web gateway. DataPower comes in three different varieties: the physical box for extremely high-speed transactional processing, a virtual edition which can be run inside a VM or installed as an RPM on top of a pre-existing Linux operating system, or the Docker version for more continuous deployment / improvement or a Kubernetes style environment. The cool thing about the Docker version of DataPower is it's completely free. So you can just go onto Docker Hub, pull it down and give it a go. The other cool thing about DataPower is because it works inside a Docker container, you can easily exec inside Docker and have a look around. So we can run a Docker exec on this Docker container, and now we are running inside DataPower, so we can have a look around. We can see the drouter process running here, which is the heart of DataPower. We have dpmon, which is like a version of nmon, which is collecting analytics about the performance of DataPower. And this is the interesting bit and sort of where the journey begins. DataPower has a inbuilt Redis server. So what we can do is we can utilize netcat to connect to that inbuilt Redis server. And if we try and run info, we get an error message saying authentication is required for this Redis server. So we can easily just do a find inside the DataPower container for the redis.conf. There it is. And if we cat that, we can see that DataPower is configured to use a hard-coded password for authentication to Redis, which interestingly, if you have a look at the Redis documentation, just requires it to be plain text, so there's no password hashing or anything involved. So the password in the config file is the actual password. So then if we rerun the netcat connection, we can authenticate to Redis, which we get an OK, and then we can bring up the information about this Redis server, and if we scroll all the way to the top, we can find that it's running Redis version 5.05. Then we give that a Google, and we come to this interesting paper by Pavel Topokov, which covers some really interesting exploitation techniques against Redis, including the rogue Redis server. This is how the rogue Redis server attack works. We have the Redis server inside DataPower, and then we have a rogue Redis server that the attacker controls that they're running on their own computer. First, we issue a command to the DataPower Redis server to change the default file name for the Redis database to dpshell.so, which we'll get back to in a moment. Then we send a command to the server to make it a slave of the attacker-controlled Redis server. The DataPower Redis server sends a little hello message, and then the rogue Redis server says hello back, and then the DataPower says, I would like to synchronize my Redis database with yours. At this point, the rogue Redis server says, I want you to disregard everything that you have. I'm going to send you a full sync, which is the entire database that I want you to save the second you get it. However, Instead of actually sending the database, the rogue server sends some shell code, which in this case is an executable file that can be used to mount a reverse connection and access the underlying operating system. The rogue Redis server then saves that directly in the file name that we specified, dpshell.so. SO in this case being a static object which can then be loaded back into Redis. So that's the remote code getting put there, and then we execute the module load command to load that remote code inside the DataPower Redis server. We can now execute and have full control over the code running inside DataPower Redis. Right, job done then. Well, not quite. The only problem is that the DataPower Redis server is listening on localhost, so we need to trick DataPower somehow into connecting to its own Redis server. The next thing I did was start up a new instance of the DataPower Docker container and configure the web GUI so I could log on and look at all the options through a web browser. Once I did that, I logged in and just started having a generic poke around until I came across this test message function. I can enter a URL and then give it some form of XML request that it wants to send, make a call, and then DataPower will send that request, in this case to my website, and then I can see the response from it. But then what is interesting is if I exec inside DataPower and start up a Netcat listener, I can then use DataPower to connect on localhost to itself. Next, if we have the transaction sent by DataPower via the test connection on the right hand side, which is this, and then we connect to the DataPower Redis on the left hand side, what you may notice is Redis commands like set apple pie, for example, and then get apple are very similar to HTTP in the sense that they're both plain text. If we ignore the XML section here, the top part of the HTTP transaction is the same. You know, it has a key and then it has a value. So what we can do is we can sort of use plain HTTP to hide a Redis commands inside them, and this is sort of the start of a cross-site request forgery attack. So for example here we're setting the request headers as Redis commands, and then when we make the call there we can see that they get embedded in the HTTP transaction. And as Redis is sort of reading through this, it would sort of say, oh, post, I don't know what that is, connection, don't know what that is, you sent me a set command, oh, I do know what that is, and then get, it would understand that, and then the rest here would error out. But the fact is that we can successfully send the Redis commands that we want to by manipulating the test message form. Finally, we can utilize the inspect tool inside Firefox to actually look at what the request is sending, and then if we do that we can see here it's sending some XML to DataPower. So you can right click and do edit and resend, and it will bring up the raw transaction. And what we can do here is where it says the header name and then the value, we can manipulate this to then make it a multi-line. And what this allows us to do is, because at the end here DataPower is always going to add the colon because it's just part of a HTTP header, but we can manipulate that by specifying multiple commands like the get or the set or the auth command or that slave of command, all in a multi-line XML request. And this just means that we can get even more flexibility out of using this form than we would traditionally get in the actual HTML version, because it doesn't let you specify multi-line bits in the actual website. But if we manipulate the raw AJAX request, we can get it to do whatever we want. So, to summarize, number one, the Redis inside DataPower is vulnerable to a remote code execution exploit using the rogue Redis server. And Googling around, there are some open source Python proof of concepts showing how this can be implemented. Number two, DataPower uses a hard-coded password to protect its internal Redis server, which we can use in this attack. And third and finally, we can manipulate and exploit the test connection function to inject Redis commands inside DataPower by fiddling with the HTTP request and force it to connect to localhost where the internal Redis server is listening. So then, using the Python proof of concept as a base, we can take the Redis rogue server combined with the DataPower test connection exploit and wrap it all together, in this case Golang, to implement our own proof of concept, and also add some additional wrappers for the Redis password that we need to use for the internal Redis server, and a wrapper around the DataPower login script, as the only way to access the test connection feature is by logging in. So finally, as a proper test, we create a new Docker instance and we configure the web GUI on that so we can access everything via the website. Save the memory on DataPower, log into it with the default admin account, and then we create a new account on DataPower which we're going to call TomTest, and we're going to grant this a group-based read-only permission, so this user can only read stuff on DataPower and nothing else. And then we're just going to save all of that configuration and give it a go. So here we are, this is the final step. We've got the Golang program compiled, we're targeting the DataPower IP address. We've got that internal Redis password loaded as an environment variable with a bash. The fake Redis or rogue server is going to be running on this IP address, which is the IP address of this server, and we're specifying the port. This is the C-based special SO Redis module that we discussed previously, which is going to allow us to have a remote shell or a reverse shell inside DataPower, and we're logging in via the web GUI with that TomTest user, and his password is TomTest. So we're going to hit enter, and it's going to log in to DataPower, got the login cookie, attempting the exploit via the test connection thing. Our little rogue Redis server is doing that hello thing. It's going to upload the module, payload has been delivered, and then it's going to request a reverse shell, and there we are, got reverse shell. So we can run the ID, and we can see that we're running inside DataPower as the derouter user, and we can run a ps-ef, and we can see that, yeah, we are now running inside DataPower, and we can do like an ls, and we can like do whatever we want inside DataPower. Inside the Docker container, derouter is the highest privilege because it's restricted by Docker, but on the actual DataPower virtual appliance, this would be root because the Redis application runs as root on the virtual appliance. As a further example, I'm going to log into DataPower as the admin user. I'm then going to go over to the crypto tools section, and I'm going to generate a non-exportable RSA certificate, self-signed certificate key pair inside DataPower, and then I'm just going to go over to the file browser, and I'm going to then try and view the private key, and DataPower won't let me. It says you're not allowed to do that. However, inside our little reverse shell that we've got using this exploit, I can just do a find to look for it and then cat the private key material. So yeah, that is a full proof of concept of the exploit. Thank you very much.